Hi all the students, today here I am in front of you all to discuss the part 4 of your motion. Now the part 4 is going to discuss about the graphs. So graphical representation of distance time and velocity time. Now how do you represent distance time and velocity time graph is in this way. Like on y-axis you will take an dependent quantity, on x-axis you will be taking an independent quantity. Now let me show you that over here. Now when you are taking this graph, one second. Now when you are taking distance time graph and velocity time graph, we will go with distance time graph concept right now. Now in this concept you can go with the first thing over here is distance is taken on y-axis. Distance is taken on y-axis and time is taken on x-axis. Now when you are taking distance time graph over here, if the graph is a straight line, that means what indicates over here the increase in time, the increase in distance, like how much time you are taking. Like for example, for 5 seconds, for first 5 seconds you are almost covering 10 meters of distance. This is in meters and this is in seconds. For first 5 seconds you have covered a gap of or distance of 10 meters, and again for 5 to 10, for that means 10 minus 5, again you are going to get 5, that means 10 minus 5, again you are going to take a gap of 20 minus 10. 20 minus 10 is again 10. So for 5 seconds you have traveled 10 meters distance over here. Again for another 5, like how do you find it? This is another 5, upper limit minus lower limit. So that is 10 minus 5, you are going to get 5. So for each and every 5 seconds you are moving a distance of 10 meters, right? So this is called as uniform motion. Okay, this is called as uniform speed. That is called as uniform speed. Your speed is uniform. That means you can find it out over here. Now how do you say that it is a uniform speed and how do you find it out, sir? We can find out by using the speed formula. Speed is nothing but distance by time. Distance by time. Now when you are taking the distance over here 10 minus 0. So when you are taking the distance 10 minus 0, so 10 minus 0 is 10 minus 0 by time is 5 seconds. So let us take in the first 5 seconds the speed is 10 by 5, which is 2 meter per second. It is 2 meter per second. So for again next case, for next 5 to 10 seconds also, your time gap is 10 by 5. That means you will be having 20 minus 10 by 5, which is 10 by 5, which is again 2 meter per second. So wherever you calculate for whatever 5 interval time gap, every time you are going to get the graph in a linear manner. So there will be a slope, very constant slope will be there. Then distance time graph, whenever it represents a constant growth in it without bending, like not curve, it is a straight line. So if the slope is like this, then that particular body is said to be in uniform speed. That is called as uniform speed, and this is the graph of it. Right? Now this is how you calculate it. S2 minus S1 by T2 minus T1 is its way of representing. Now S2 minus S1 by T2 minus T1 means upper distance by lower distance on y-axis by x-axis. So you will be getting the slope. The slope of VT graph, the slope of velocity time graph gives you, distance time graph gives you velocity. The slope of distance time graph gives you velocity. So this is the formula. How do you find out the velocity? and this is the way you will calculate what is the distance traveled, and this is the way you will calculate what is the time traveled, so time taken, and that is how you will find out the speed. If the speed is constant throughout your journey, then it is called as uniform speed. Now let us get into the next one. This graph is for non-uniform motion, like non-uniform speed. This is for non-uniform speed. You can tell that this is a non-uniform speed. For a non-uniform speed, the graph is going to be a curved graph. It's not going to be a straight line, it is going to be a curved graph. And this is in meters, this is in seconds. So whenever you get a curved graph, then that means you can say that your speed is not constant, right? So this is non-uniform speed, okay? Non-linear graph. So next one. Here, coming to this one, you have another thing, like this graph is velocity time graph. When you are going with velocity time graph, here you will be having the change in velocity. You have to find out again the slope, like change in velocity by time. So y by x, that means velocity by time. So delta v, change in velocity by time, is going to give you acceleration. The slope of velocity time graph is going to give you acceleration. Okay, so determine the distance traveled by the body to determine, like for example, if you are taking this particular graph, you can observe this graph for first 5 seconds, it is at A point, and next 15th point it is at B, and at 10th point it is at this point only. So if you observe, there is no change in velocity. If there is no change in velocity time graph, that means we can say it is a constant velocity. If there is a constant velocity, that means velocity is not changing. It is throughout the journey, it is 20 meter per second or 20 kilometer per hour. So when if it is 20 kilometer per hour throughout the journey, then we say that this particular graph is representing you that it is acceleration is 0, because there is no change in velocity. 0 by anything is 0. So now you are going to get, now if you want to find how much distance did he travel while he is traveling with that much of speed, like for example he is traveling with 20 km per hour velocity. Now how much distance did he cover? If I ask you that question, now area of this particular field, that means area of this particular field, for example if you are taking from 5 to 15, from 5 let us take 5 is t1, 5 is t1, okay, you can find that area. Now let us take 5 is time t1 and 15 is time t2. From t1 to t2, if you are finding the area of velocity time graph, that means you will be getting it like a rectangle, like you are getting it like a rectangle. You can say this. Now this rectangle, if you find the area of this rectangle, length into breadth, okay, length into breadth, then you will be getting, this side is 20, this side is 15 minus 5 is 10. So 20 and 10. So 20 into 10. 20 is velocity, and 10 is the time. So area, if you want to find, you should multiply this 20 with this 10, then you can find this area. This area is nothing but it is going to represent you the distance. It is going to represent you the distance. Okay? So clear. I hope this velocity time graph is also clear for you. Now let us go into some more detailed clarification of this particular thing of graphs. Now here we have velocity time graph. If it is a constant increase, that means it is increasing constantly. That means acceleration is increasing. Now this is a slope. When you are getting a graph in the form of a slope, then you can say that this body is in a slope. Like for example, you are getting it in the form of a slope. So now, if you are trying to find the slope, now what happens over here is, if you try to find the area of this slope from particular point to another point, then this is nothing but half base into height, which is like a triangle. So when you find out that area, it represents you, it is going to give you distance. Distance is equals to half base into height. Now how do you find that half base into height? Half base into height. Now how do you find out that? Over here is half, what is the base? 30 minus 10, it's 20. 20 into h is how much? Height is 30 minus 10, 20. So how much you will be getting? You will be getting 400 by 2. Right? So your displacement is, your distance is 200. Distance traveled by the object is 200 meters. Okay, so this is how you solve it. Now you can get this particular distance by using this formula, by finding the area. Right? Now let us get into the next problem, next thing. Now these are the two different graphs which are going to represent you a time graph of a uniformly decelerated motion. But for example, when you are riding your vehicle, when you reduce your speed by putting some brakes or something, your vehicle continuously comes down the speed. Like if the speed is coming down constantly, like for example, if your velocity is coming down constantly like this, then you can get this. If your speed is reducing constantly, like constantly, it got reduced. When it is getting reduced constantly, then you can say that it is changing uniformly. So that change is called as uniformly decelerated motion. This is called as uniformly decelerated motion. You can also get with velocity time graph. That means you are decreasing your speed. When you are decreasing your speed with respect to time, your acceleration which you are going to get is called as decelerated motion. Like decelerated motion, this is reducing your speed. That means your acceleration is coming down. So that word acceleration coming down is represented with decelerated. Now another thing, the graph which is going in this way, the slope, then that is called as decelerated graph, velocity time graph. And now if you are taking velocity time graph in a zigzag manner, like it is continuously changing and it is not having a proper shape, like or something like, then you can say that it is a non-uniform accelerated. Sometimes you are raising your vehicle speed or sometimes you are decreasing your vehicle speed. Then the graph is going to come in this manner. So this is the concept of graphs, kids. Hope this is very clear for you, and let us meet with part 5 in the next assignment. In the next video. Until then, bye.